So the next topic we want to learn about is Friedel alkylation. So here how it goes. So it also follows electrophilic aromatic substitution mechanism. So the word alkylation, so it might be clear to you that we are trying to place alkyl group on the benzene ring. Okay, so this is how it goes. So this is your benzene ring, and you try to put the methyl group on the benzene ring. This is alkylating your benzene ring. This is known as alkylation. So what are the reagents we are going to use here are this CH3Cl and AlCl3. Okay. So let's go into the mechanism. So CH3 should be your electrophile so that you can place it on the benzene ring. Now you should be able to understand that. So CH3Cl, since it is donating electrons to this other reagent AlCl3, so this is acting as a Lewis base, and this one, since it is accepting the electron pair from this one, it is acting as a Lewis acid. You might want to recall your Lewis acid and Lewis base definitions. Now, since this donated the electron pair, it requires a formal negative charge, and since this one lost the electron pair, and the this chlorine will go ahead and attack it here. So it will become AlCl4 negative, and this one will become positive since it lost the fluorine one. So this is your electrophile ready to attack on the benzene ring. Let's go ahead and watch how it does. So this is your benzene ring with the hydrogen here. So what will happen? This benzene, this double bond will go ahead and attack here. So I should put it on the arrow here. Let me just do that. This is how it goes here. So this double bond will go ahead and attack it here. So what will happen? So you have your CH3 substituted here, and this carbon bears the positive charge. So there was a double bond here. Okay, it attacked on the CH3, so CH3 got substituted here. It came here, it added here, and then this is your plus charge on this carbon. Now you know the next step. You are going to react it with the base. Okay, so this base will go ahead and attack on this hydrogen. This bond will move here and restore the aromaticity. So you already know that to react with the benzene, which has the aromaticity, which is quite stable, if you want to put something here, you need a electrophile to do so. So the CH3 is here. So this is a product of this reaction, and this we call it as alkylation of the benzene. Now this reaction does have some limitations. So we are going to talk about those. The first one is the polyalkylation. Now what do we understand by polyalkylation? So by polyalkylation we mean that when this reaction proceeds, this benzene ring reacts with these two reagents. So you do get this as your product, but there are chances that this reaction will proceed further, and what will happen? You will get more and more alkyl groups attached to the benzene ring. And if you want this as a product, then it's not a problem. But what if you just want only one methyl group attached to the benzene ring? Then it is a problem. So when you have more than one substitution of CH3 groups or your alkyl groups to the benzene, we call it polyalkylation. But we do have a way to get around it. So what we can do is to stop this, we can increase the concentration of benzene ring. Benzene, okay. So if you increase the concentration of benzene, so the more and more of this CH3 is going to attack the more the other benzenes, and you can avoid forming more of your alkylated product. So the way to get around this problem of polyalkylation, if you just want to put one alkyl group on your benzene ring, so you just add a lot of benzene so that you can avoid the polyalkylation of the benzene ring. So this was the first limitation. The second limitation is carbocation rearrangement of the alkyl halide. So I'm going to write carbocation, and we will discuss it. Rearrangement of alkyl halide. So what we have in front of us is this benzene ring, and it reacts with this reagent CH3, CH2, CH2Cl, and AlCl3. But what we noticed in our this mechanism on the of the previous reaction, that we do get the carbocation from this one. So what we should expect that this should be our carbocation, since Cl leaves from here, which leaves the positive charge on this carbon, and you have AlCl4 negative as your other species. Now, what happens here is that you might expect that this should be your product here, but this is not the case, okay? Because we have learned already, because this is a primary carbocation. So this is a primary carbocation, and primary carbocations are less stable than the secondary one. And what will happen, a hydride shift will happen here. So I'll show you how. So CH3, CH2, and CH2, which is your this primary carbocation. So what will happen, let me show you this one as let me emphasize this hydrogen here, um, and then we will see what is happening here. So what will happen, this hydride shift is going to happen here. So what will happen, this hydrogen bond here will shift towards this carbon, and this carbocation, the positive charge which was present earlier here, will shift here, okay? So this is known as the hydride shift, and let me show you the result of this move here. So it will give you CH3, and this carbon bears the positive charge now and has CH, and then this is your CH2. So remember, this is your secondary carbocation, and you know this is possible because this is leading to the extra stability, and whatever leads to extra stability is always welcome in the reactions. So what should be the product here? So that means this is your carbocation. There is a rearrangement happening here, and so it will lead to the product, this product here. So this is what we call as the um, carbocation rearrangement. So CH3, CH, and your CH2 here. Does it make sense? I hope so. So this is your product, the one which you were not expecting. Okay. So this is another limitation of the Friedel craft alkylation, and the last one, the third one is reaction does not take place with vinyl halides. Okay, so if you have your benzene ring here, and then you have a reagent like this, where your carbon connected to Cl is involved in a double bond. Okay, so we call this carbon here as vinyl halide. So this reagent is a vinyl halide, and these types of reagents you can't do Friedel-Crafts alkylation. They are not allowed in Friedel-Crafts alkylation. So no alkylation will take place in this case. So you call this one as no reaction. Okay, so this is the third and the last limitation.